Hello everyone. I am Arsh Attri from IIT Roorkee and welcome to my presentation on the topic Anomaly Detection in Time Series Signal for the course PHN 313, I guess, Signals and System. Here I'll be discussing about anomaly detection in time series signal. Let's go to the presentation. So, first I'll be introducing what is actually anomaly detection. Anomaly detection in time series signal refers to the process of identifying unusual patterns or data points in time series data that deviate significantly from the expected behavior. Time series data consist of sequential observations over time, often representing phenomena like stock prices, temperature changes, network traffic, or machine performance matrices. Detecting anomalies is in such data is crucial because these deviations can indicate important events such as system failure, fraud, or significant changes in underlying process. Anomalies can be classified into different types including point anomalies, a single data point, or conceptual anomalies, unusual, a specific context, and collective anomalies, anomalous group behavior. Given the complexity of time series data, anomaly detection is challenging and requires advanced techniques such as statistical methods, machine learning, and deep learning approaches. It its important span multiple industries include finance, healthcare, manufacturing, and cybersecurity, where early detection of anomalies helps prevent critical failures, reduce risk, and improve operational efficiency. Okay, let's go to the next slide. So now let's discuss about importance of anomaly detection. Detecting anomalies in time series data can help to identify potential issues before they cause significant problems. Applications include, some of the applications which I have listed includes fraud detection in financial transactions. It includes identifying irregularity patterns in banking transaction, credit card usage, or stock market activities that indicate fraudulent behavior. Another important application is in healthcare monitoring. Detecting anomalies in patient health data such as heart rate, blood pressure, or glucose levels that may signal potential medical emergencies. And I have also listed one more important application of anomaly detection, which is in fault detection in industrial systems, monitoring machinery and equipment to detect unusual behavior or failures, preventing costly breakdowns and reducing downtime in manufacturing and production. We will be discussing all these three applications in detail in the upcoming slides. Types of anomaly. First, now we'll discuss type of anomaly detection task. There are two types. So I've classified them into two types. One is point-wise anomaly detection, and the next is pattern-wise anomaly detection. In point-wise anomaly detection, you look at isolated points in times that are outliers. In the first diagram on the left side, there are two distinct points, which these points are anomaly points because they differ than the rest of the points. But since it is point wise, so it is known as point. So here we use point wise anomaly detection, and the second is pattern wise anomaly detection. Here we are looking to identify a sequence of points that form an anomalous pattern. Like in the second diagram, like these group of points, they differ than the rest of the data, so they come in pattern wise anomaly detection. And time series data overview. Let's discuss it. Time series data consists of sequence of values at different time intervals. Common features include trends, seasonality, and noise. First I will explain what do I mean by trend. A trend refers to long-term increase or decrease in the data value over time. For instance, a gradual upward trend in stock prices or a downward trend in temperature levels. Trend can be linear or non-linear. So now I'll be discussing about seasonality. Seasonality refers to recurring patterns or fluctuations in the data that occur at regular intervals, such as daily, monthly, or yearly. For example, retail sales might peak during holiday seasons every year. And now I'll be telling you about what is noise. Noise refers to random fluctuations or variation in data that do not uh, okay. So now I'll be discussing about techniques of anomaly detection. So uh, there are four methods. One is statistical method, other is machine learning method, the next is deep learning approaches, and the next is hybrid approaches. We will be discussing every one of them in detail. So first I will discuss what do I mean by statistical method. In statistical method rely on probabilistic models such as robust z-score method, mean, absolute deviation. So in this method, like rz is equal to actual data point minus mean upon its deviation, like I have shown, like this is the formula. And when data is normally distributed, we can reasonably conclude that points at each tail are outliers. Okay, and when z is above 3 or 3.5, usually we conclude that it is an outlier. Now I will discuss machine learning models. Machine learning approaches involve supervised and unsupervised learning. The method which I'll be discussing in machine learning model is isolation forest. Three based algorithm. It is also known as tree based algorithm to detect outliers. Here partitions the data to isolate points. If we require many partitions, means the point is linear. If we require few partitions, means the point is outlier. Like in my first like in the first photo, there are many partitions to describe this data. So it means it is showing linear behavior. And in the next, our outlier point is being shown by few partitions, mean the point is outlier. Now hybrid approaches is nothing but just combining statistical methods, machine learning, and deep learning techniques can provide more robust anomaly detection system. Hybrid approaches are increasingly popular in complex domain. Now let's discuss about some applications of anomaly detection. So like I've previously said it in the first few slides, it is using fraud detection in finance, network intrusion detection, fraud detection in manufacturing, and predictive streaming. Okay, so now let's see what the tools and libraries we need. So in Python, I have mentioned some tools and libraries here, like Python, R, and MATLAB. In MATLAB, a signal processing toolbox. So let's move further. Now I will be discussing about future trends in anomaly detection. So there are three important future trends, which includes, one is edge computing and IoT for real-time detection. The second is explainable AI, which is also known as XAI for anomaly interpretation, and the third is self-supervised learning. So first I'll be discussing edge computing and IoT for real-time detection. So this includes the latency involved in transmitting data to centralized servers, making it possible to detect and respond to anomalies instantaneously in critical applications like smart cities, autonomous vehicles, and industry IoT. Now let's discuss XAI for anomaly interpretation. In anomaly detection, particularly in sensitive industries like finance, it's crucial to understand why they occurred. XAI helps build trust by offering insights into the decision-making process behind identifying anomalies. Now, self-supervised learning. In time series data where labeled anomalies are often scarce or difficult. So like I've mentioned here, the self-supervised learning. Okay, so let's now jump onto the conclusion that what we have discussed. Anomaly detection in time series data is a critical tool in a variety of fields. With the rise of AI and deep learning, more advanced models are being developed, providing greater accuracy and scalability in detecting anomalies. Thank you.